Today's notes are on solving systems of equations and inequalities, and they're very similar to what we've been doing for the past 2 days. We're going to have you graph, and if you remember from last chapter, we're also going to solve a system by finding intersection points. Now the tricky part here is that we're going to mix lines and absolute value equations and inequalities together. And so when you look at number 1, f of x does not have an absolute value around it, so that means that this one is linear. And when we graph lines, we plot the y-intercept first. So I go to 0, 0, and I'm going to move up 3 spaces. And the slope on this line is -1, so I will go down 1 space and to the right 1 space. And because this is a system and we don't know where it's going to intersect, I need the line to extend over the graph paper. So I'm also going to go up 1 and left 1 space. And this should be a line because it's linear. It should not be the V shape. It does not have the absolute value. G of x does have the absolute value. So when you graph this one, it should look like a V. The past 2 days we learned that -2 moves this to the right 2 and -5 moves it down 5. So I'm going to go right 2, down 5, and there's my vertex. The invisible multiplier out in front is 1, so I'm going to go up 1 over 1 on the right side of the graph. And instead of doing the opposite like I just did on the line up above, I'm going to go up 1, left 1, and create a V shape. And the solution to my system is the intersection point that's right here. It's at 5, -2. On number 2, f of x again is linear. It does not have the absolute value symbol, so I plot the y-intercept first, which is 7. The slope is -2, so I go down 2 to the right 1. And I do the opposite up to left 1 on the other side. It should not look like a V, it's a line. G of x is the absolute value, so it should look like a V. It's going to move to the left 3 and up 7. And the multiplier out in front is a -1, so that's going to reflect it. We're going to go down 1, right 1. And on the other side, do not do the opposite. Go down 1 again, but go left 1 to create the V. Again, the intersection point is the solution. That's at 3, 1. On number 3, we have one of the special cases for our line. This is a vertical line. Every point on the line is going to have an x-coordinate of 6. So these points all have x-coordinates of 6. F of x has the absolute value symbol, so this one is the V. It moves to the right 3 spaces and up 2 spaces. And has an invisible 1 out in front, so we go up 1, right 1. And on the other side, up 1, left 1. The intersection point is at 6, 5. This one we're mixing it up a little bit. The V absolute value is on the top. We're going to move right 4 and up 4. The multiplier out in front is negative 1/2, so we go down 1 and to the right 2. On the other side, down 1 to the left 2. It should look like a V. It has the absolute value symbols. G of x does not have the absolute value symbol, so it's linear. The y-intercept is 1, so I go up 1 space on the y-axis. The slope is 1/3, so I can go up 1 and right 3. I can also go down 1 and left 3. And this one is a little bit different. Because last chapter, when we only worked with lines, we said there could be one solution, no solution, or infinitely many solutions. But when we start mixing the different shapes of these graphs here, a V and a line can intersect twice. My blue line is a little bit off here. The points are correct. But this one has two solutions. One is at -6, -1, and the other one is at +6, +3. Just so you recall, if I were working with a greater than or less than symbol in the inequalities, there's a dashed graph. When it has the equal to symbol underneath it, it's a solid graph. When we do the shading, if it's greater than or equal to, you shade above the graph. And my hint to you was you could look at it as above the vertex. And if it's less than or equal to, it's below the graph or below the vertex. When I go to solve a system of inequalities, I'm going to be shading. So for the first one, it's an absolute value, so it's going to be a V. It will move to the left 4 spaces and down 5 spaces. The multiplier out in front is the invisible 1, so up 1 over 1. On both sides. This one has an equal to symbol, so it's a solid graph. And the greater than symbol tells me to shade above the vertex. So this one's going to get shaded inside of the absolute value. I'm not actually going to shade it yet. I haven't drawn the second inequality. So the second one is linear. It does not have the absolute value symbols. That means that I'm going to plot the y-intercept first, which is at 0, 3. The slope is 2/5, so I'm going to go up 2 and right 5. On the other side, I do the opposite, down 2, left 5. It is okay that these don't intersect at nice points. Again, we're looking for a shaded region, not an intersection point. This one does not have the equal to symbol, so it's a dashed line. And it's a greater than symbol, which means I'm going to shade above the line. So if I'm looking at my graph right now, I'm not going to shade down here on the bottom because none of the arrows are pointing towards here. Over on the right, there's this little almost triangular section. The orange arrows are pointing here, but the blue ones are not. In the middle, the blue arrows, are pointing here, but the orange ones are not. Over on the side, the orange ones are, but the blue ones are pointing away. If it's hard to see, I'll put another one on there. And this section that's kind of up at the top right here, that's above the orange line and inside the absolute value is where all of my arrows are pointing. Down here it says a point. In the directions it says identify a point in the solution set. You pick your favorite point. I'm going to pick this one right here, -5, 5. As long as it's in the shaded area, and it actually cannot be one of the intersection points if there was a nice one, because one of the lines is dashed, and when it's a dashed line, it's not included. So as long as it falls within the shaded section, it's good. On number 6, the first graph is an absolute value, has a V, or has the absolute value, it's a V. It's moved up 5 spaces. The multiplier in front is a -1, so I'm going to go down 1 space and to the right 1 space. Again, it has an absolute value symbol, so it's a V. On the other side, we still go down, but we go left 1 space. It does not have an equal to symbol, so we're going to draw it dashed. And the less than tells me to shade underneath the graph. So down from the vertex, anything that's inside the V on this one. The second graph also has absolute value, so it's also a V. It moves down 2 spaces. The invisible multiplier out in front is 1, so I'm going to go up 1 space and to the right 1 space. Or up 1 space and left 1 space. It should look like a V, not a line. It has an equal to symbol, so it's solid. And it's a greater than symbol, so I shade above the vertex or inside the V. Again, if I look at all the sections, anything down here has blue arrows pointing to it, but the purple arrows are not. On the 2 sides, none of the arrows are pointing to those 2 sides. Above the graph, the purple arrows are pointing here, but the blue ones are not. The answer is this little quadrilateral, and I can't get, there we go. Shade all those little pieces in there. Pick a point, like 0, 0, that's a pretty easy one. As long as it's in the shaded area, it cannot be on the blue graph or an intersection point because the blue graph is dashed and so it doesn't include those values. Next one, f of x is a line. It's linear. It does not have the absolute values, so I plot 0, 4. The slope is 1/2. So I'm going to go up 1 and to the right 2 spaces. Or the opposite, down 1, left 2 spaces. It's a line, it's not an absolute value. This one has the equal to symbol, so it's a solid line. The inequality is less than, so we're going to shade below the line. G of x has the absolute value symbol, so it's a V. It moves down 1 space from 0, 0. The multiplier out in front is 2, so I'm going to go up 2 spaces and to the right 1 space. On the left side, I'm still going to go up 2, but to the left 1 space. It's dashed because it does not have the equal to symbol. And it's a less than symbol, so from the vertex, I'm going to shade down, which is everything outside of the absolute value V. So the area that has the overlapping arrows, where both blue and purple arrows are pointing to it, is everything that's below the purple V and also below the blue line. Pick your favorite point. I'm going to use 5, 0. As long as it's in the shaded area, it is a solution. Last part, you need to be able to write the system as well. So if I look at the green graph here, the vertex is at 2, comma, -1. That means that it moved to the right 2 spaces, so I'm going to put an x minus 2 in the absolute value and down 1 space. The multiplier is up 3 spaces and to the right 1 space. I'm going to give it an f of x, and it's not shaded, so it's an equal to. The blue graph is a line, so I'm going to find the y-intercept first, which is at 4. And then I'm going to look for the slope. I go down 2 spaces, right 1 space, I'm sorry, right 3 spaces. Down 2 is a -2 over 3. I'm going to call this one g of x, something different. And it's an equation because there is no shading. On number 9, the absolute value has a vertex at -1, 0. To move it to the left 1, I'm going to put x plus 1 inside the absolute value. It's a dashed line, so it doesn't get an equal to symbol. The shading is actually below the graph. If I draw the arrows on the left and the right side of the graph, they're pointing down towards the shading, so it's a less than symbol. And just a quick check of the multiplier here, it looks like we're going up 1 over 1, so I don't need to fill in a 1 out in front. For the line, this is a special case one, it's a horizontal line. So I'm going to use g of x. You could use y if you want to, that's fine. The line is at 3, and the shading is above that line, so it's a greater than symbol. Last one, the absolute value. The vertex is at 1, 5. To move to the right 1, I'm going to do x minus 1 in the absolute value. Up 5 is plus 5. It's a solid line, so I'm going to put an equal to symbol. It's shaded below the vertex, so it's a less than symbol. And my multiplier is 1, but it is reflected, and so there's an invisible -1 out in front of the absolute value symbol. The line, again, is a horizontal line, so I'm going to use g of x. It's at 2, and the shading is above, so it gets a greater than symbol. For the last part, we'll need our graphing calculator. And what I'm going to do is go to my y equals and type in each of these 2 equations. So if I hit y equals, in order to type in the absolute value, you need to press the math key. The right arrow key will get you over to number, and the very first one is absolute value. X plus 3. I'm sorry, wrong one. 2x minus 5. And the second one is 4 minus, again, absolute value is math, right arrow, very first one, x minus 3. In case your window changed, it still should be from -10 to +10. I'm going to hit graph. I have 2 absolute value graphs. There's 2 solutions. One of them is right here where the graphs intersect on the left, and the other one is on the right. 2 chapters ago, we hit second trace, and we selected number 5. We're looking for an intersection point. And basically what I'm going to do is get my cursor closer to the intersection point. Doesn't matter which side it's on, left or right, it's just going to be closer to the point. Hit enter. Then it'll move it to the red graph, hit enter again, and it'll say guess, so hit enter one more time. My intersection point is down here at the bottom. I happen to know that 1.3 repeating is 4 over 3, but what you could do is you could go to your main screen and type alpha and find the letter X. Math, enter, enter, will change that value to a fraction for you. I can also do alpha y, math, enter, enter, and my coordinate is at 4/3, 7/3. If I go back to the graph, I'm going to do second trace one more time and pick number 5. I'm going to get my cursor closer to the other intersection point. Doesn't matter where it is as long as it's closer. I'm going to hit enter because it's on the blue curve. I'm going to hit enter when it's on the red curve, and then I'm going to have it guess. It says the answer is 4, 3. So for number 12, I go back to my y equals. I clear out my equations. I type in the new ones, -1 divided by 3. Absolute value is math over to number, x minus 3, outside the absolute value plus 1. And I have -1.7x minus 1. There's the v, there's the line. Second trace, select number 5. My cursor's pretty close, I like that. I'm going to hit enter because it's on the blue one, enter because it's on the red one, and then have it guess. Again, I can go back to the main screen and do alpha x math, enter, enter. I can do alpha y math, enter, enter. And -30 over 61, -10 over 61. Last one, go back to your y equals, clear out everything that's in here. Math over to number, first one is absolute value, x plus 3. Minus math over to number, x plus 1. Second equation is 1/2 x plus 2. Hit graph. This one has 3 intersection points. There's one over here, there's one on the left right here, and there's another one on the right here. So second trace, number 5. I'm going to move my cursor over to the other one. I'm sorry, not the other one, the left intersection point. It's pretty close. Enter for the blue, enter for the red, enter one more time for guess. -8, -2. Second trace, number 5. Move that cursor back closer to the other intersection point. It might be quicker if I go up to the red graph first. Looks like that might take me less time. Pretty close. Enter for the red, enter for the blue, enter one more time. -4/3, +4/3. Second trace, number 5 again. Get it closer to the other intersection point. Enter for the blue, enter for the red, enter for guess. Now if you get something like this, this means times 10 to the -14th power. That means move the decimal point 14 spaces to the left. That number is so small that we just consider it 0 if that ever shows up on your calculator. 0.2 is the answer.